Hello everyone. Develop green buildings and constantly promote green and low-carbon development. Promote harmony between man and nature. Prefabricated buildings actively respond to the National Green Building Development Strategy. In such an era background, we should keep up with the pace of the times. Please follow me to open the door of prefabricated learning. Let's welcome enterprise teacher Zhang Lindsay to explain to you.
Everyone, let's explain the detailed drawing of the inner wall panel without openings. In this lecture, the reference atlas is 15G365 to 2 prefabricated concrete shear wall inner wall. And in the same series as this atlas, that is 15G36521, prefabricated concrete shear wall outer wall, which you can refer to and study together. As always, let's start with the numbered drawing of the inner wall of the shear wall. This is the cover of our reference atlas. There are 4 types of prefabricated interior wall panels, including the interior wall without opening, the interior wall of fixed door buttress, the interior wall of middle door opening, and the interior wall of tool holder. The number list of the inner wall without opening is NQ2128. NQ is an acronym of the inner wall. 21 is its mark width. As for the floor height, 28 is its layer height of 2,800. The number of the inner wall of the fixed door buttress is NQM1. NQM is actually the inner wall with doors, and M is the abbreviation of the door, and 1. It means that the fixed door buttress 3028 is the same as the inner wall without opening. The mark width is 3,000 and the layer height is 2,800. The 0921 in the back is the width and height of a door. The main difference between the inner wall of the middle door opening and the inner wall of the fixed door buttress in the front is NQ1, is NQM1, and the other is NQM2. The inner wall of the middle door opening is NQM2. 3029 means the width of the sign is 3,000 and the story height is 2,900. 1022 means the width of the door is 1,000 and the height is 2,200. The inner wall of the tool holder means NQM3. 3,329 means the width of the sign is 3,300. The floor height is 2,900. 1022 represents the door width of 1,000 and a door height of 2,200. Then this drawing is a production detail of our inner wall, and it is also divided into formwork area, formwork drawing, reinforcement drawing, and the reinforcement detail of it. Then we take the drawing of NQ1A28 to identify our basic structure. First of all, let's take a look at its basic size. Through the number, we can also see that its mark width is 1,800. That is, it is circled in blue. Its width is 1,800 millimeters. Height is 2,640 millimeters. Thickness is 200 mm. And its bottom is a grouting sleeve of the sleeve. Our grouting sleeve has a total of 2 holes. We pour it from the lower part and squeeze out the slurry from the upper parts. Then go for comparison. Then we can see that it is a total of 5 pre-braided filling sleeve at the bottom. There are 2 pre-beaded hanging pieces on the top of the wallboard. The number given in the figure sheet is MJ1, which is the first piece of our buried pieces. Buried pieces, no 1. Let's look at the wall again. It can be seen on the official diagram. There are 4 pre-buried temporary support pre-buried nuts, represented by MJ2 to indicate that this is my buried parts No. 2. There is a square in the middle, and there are 2 forks in the middle of the square. A fork indicates cable box on the inside of the wall. And on the drawing, we have a total of 3 cable boxes. An embedded part required for fixing the post-cast concrete formwork is not set in our component detail drawing, but it will be placed according to our later stage. Then let's take a look at the structure of the rebar. In the basic form, it is divided into 2 layers of mesh reinforcement. The horizontal distribution reinforcement is on the outside, and the vertical distribution reinforcement is on one of its inside, leaving its horizontal distribution reinforcement. It will extend out of our wall space. For example, the horizontal distributed reinforcement on this drawing, its diameter is 8, and there are 13 horizontal distributed reinforcements in total. With the number of 3D, according to our design requirements, we need to set this horizontal densified reinforcement within the scope of our grouting sleeve, that is, our 3F reinforcement. There are 2 3F reinforcement in total with diameters of 8. We will also set a diameter of 8 at the center of the sleeve. A sleeve horizontal distribution reinforcement with a diameter of 8. Our number is 3E. Let's look at the vertical distribution reinforcement. There are mainly the following vertical distribution reinforcements. One of them is a vertical distribution reinforcement with a diameter of 16 and a number of 5. We can see that the vertical distribution reinforcement is arranged in a plum-shaped way. Another kind of vertical distribution reinforcement has a diameter of 6, and its number is the same as that of our 3A reinforcement. And at end, the opposite side reinforcement of 3A are also arranged in a plum blossom shape, stagger placement, number 3, B, and the end diameter of 12. The number of a total of 4, no, 33C reinforcement, located on the left and right sides of our wall plate. The top and bottom of a total of 1, respectively. Except for the horizontal distribution reinforcement just mentioned, and the one of our vertical distribution reinforcements. There are also 3 types of tight reinforcements in the inner wall, which are watertight reinforcements, 3 lap placed at a spacing of 600, a diameter, and a spacing of 600. We can see from the dimension that the spacing of 3 lap is just twice that of our vertical distribution reinforcement. The other is 6 in diameter. The tied reinforcements that are connected with our horizontal reinforcement and vertical distribution reinforcement are located on both sides of our wall, respectively. With a total of 26 on both sides. The third kind of tied reinforcement is a stiffener within our sleeve, which is also at the intersection of our vertical reinforcement and our horizontal reinforcement. And there are a total of 4 tied reinforcements with a diameter of 6. That is our 3 LC tied reinforcements. After talking about the structure of our reinforcement, I'll explain the diagrammatic sketch of the prefabricated interior wall, electrical appliances reserved. For the electrical appliance reserved diagrammatic sketch, we generally divide it into 3 sections, according to the low area, the middle area, and the high area. If the electrical junction box is embedded in the low area, in the middle area, we generally connect the embedded conduit downward. And the embedded conduit is the embedded position of the cable box. The lower area of the preset wallboard reserves the line connection notch. The size of the notch is generally set to 130, chained 90, 200 in our drawing set, and is set on the inside or outside of our wallboard according to needs. In our actual project, it is based on which side of us is convenient for construction. Then we will set it there. If the cable box is embedded in the high area, we usually connect the embedded wire pipe upward to the electrical pipeline in the horizontal postcast strip or postcast ring beam. If we collide with our horizontal reinforcement, when setting the reserve notch, we will generally cut the horizontal reinforcement and bend the horizontal reinforcement inward 12 times at horizontal position. Then, in the notch of the cable box, it is necessary to set the same additional horizontal reinforcement as the original horizontal reinforcement to make the reinforcement of the opening. Then, the anchorage length of the additional horizontal reinforcement deep into the wall concrete on both sides of the cable box notch should not be less than the anti-seismic protection lengths LOE in the design requirements. That's all for this lecture. Thank you.
The above is the explanation of the knowledge points in this subsection, and I wish you a happy learning journey in the process of learning the prefabricated concrete building construction course.